fine for those ones, yeah.
Okay, so this is direct proportion.
Okay. So D is directly proportional to x. So D would equal to kx.
Yeah.
And we know 30, so that would be 36 equals k5 or 5k.
Mm-hmm.
And then k is just 36 over 5, which is 7.2.
Yeah.
And so we need to find the value of D when x is 8. So D is kx. So D is 7.2 times 8, which is so 43.6, I think.
I think it'd be bigger than that, won't it?
Oh yeah, no, 57.6.
Okay. Any questions there?
No, I got that.
Okay, this one is x squared.
Okay, so y is kx squared. And we know 100 is k 5 squared, so that would be k times 5 squared. So k is just 100 over 5 squared, which is 4. So y when x is 3. So y is k squared. So yeah, so y equals 4, 3 squared, which is 36.
That's it. Okay.
Okay.
So this is gonna be the same idea.
Yeah.
Okay, how about this one?
So y is, I'll complete the table. So I'll just copy the table out really quickly.
Okay.
So if so that would be y would be, so for the first one it would be 1.
So, and how did you get that?
Because y is equal to constant over x. Oh yeah, we need to find the constant first, don't we?
Yeah.
Yeah. So then y would be k over x squared. So it would be k over 1 squared. Yeah. So
Oh, sorry, 1 over 10 squared.
yeah. So 10 is 1 over k over 10 squared. So then k is just equal to 1,000.
10 squared?
Oh, sorry, it's 100.
Yeah.
So if you know the constant is 100, so the constant, so that would be 100 over 1 squared, which is, for the first one, it would be 100. The second one would be, so y is 100 over 2 squared, which is just 100 over 4, which is 25.
Yeah.
And for 5, it would just be 100 over 5 squared, and 5 squared is 25, so that would be 4 for y.
Yeah.
And yeah, the next one would just be 1, because 10 squared is 100.
Yeah. Okay, any questions there?
I think that's okay.
Okay, that's 5 squared. Okay, so that's pretty much all of the past exam questions and each type for for proportion. Okay, so circle theorems. How do we do this?
So we know that the angle AOC would be twice the angle of ADC. So then I'll just draw the diagram really quickly. Sorry. Like that, and then then x is there. This is 67. So yeah, so we know the angle which is AOC to be, so AOC, angle AOC equals 67 times 2, which is 134 for that one. And we know that x would be 360 minus 134, which is 226.
Okay. Okay, so I think you're good there. 226. Okay, how about this one?
So that is, I'll draw the diagram again.
Okay.
So with that, we know so DO, I'm going to draw this. Yeah, so DOB, so what do we need to find? Angle DOA, so DA. Okay, that's one. Okay, so we know that this is 34 degrees here. So, and we know that because it's a tangent on the circle, so angle B would just be a 90-degree angle.
Yeah.
And because of that, so 90 plus 100. Wait, so I'll just the angle BOC. So angle BOC equals 180 minus, in brackets, 34 plus 90, which is which would be 56 degrees.
Okay.
And we know that angle we'd use the same. So would we know what do we know any other angles in the triangle OAC?
And so so if this angle is 56, this is a tangent, this is a tangent.
So that angle ACO would be also 56.
Yeah. Sorry, which one, sorry?
ACO, so is that
one? That's ACO.
Yeah, that one. Oh, is it not 50?
That one's 34.
40, okay. Sorry, I didn't quite get.
So what do you notice about the two triangles, AOC and ABC? Sorry, OBC.
They look, both BC and AC are tangents.
Yeah, so BC and AC are same length. These two angles are the same. Okay. This is going to be 90 degrees as well.
Okay. All right, and then you'd get 56 from that.
Yeah. So basically, they're similar triangles, and so that's going to be the same. And you're going to, whichever way you do it, you get the same thing.
Yeah, okay, that's fine. So if we know that this would be 56 as well, then we'd get the angle DOA. So DOA equals 180 minus, and in brackets, 56 plus 56.
Yeah.
which is 80 minus 12, which is 68 degrees.
Okay. Any questions about that one?
That's fine. No, I got that. That's good.
Okay. 68. Okay, this one.
So angle SOT. So I'll draw that one. So that would be 90 degrees for angle. Oh no, it wouldn't. No, wait. So those are two tangents there. So TPO is 24. So if we just draw a straight line through the kite shape to kind of make it in half.
Okay.
We know we know that angle TPO, so that would be 24 degrees. And because there are two tangents that come at a point, we know that the angle OPS would also be 24 degrees. And because there are two 90-degree angles, we can just work out one of the... So let's say TOP to work that out. So angle TOP equals 180 minus 90 plus 24 in a bracket, which is equal to 66 degrees. And then angle SOT is just 2 times 66, which is 132 degrees.
Okay. 2 degrees. SOT. Okay, any questions there?
That's fine. That's good.
Okay. Okay. Let's check. Yeah. 132. Okay, let's take a look at that one. Tell me what you think. I'll just be a sec. You okay, pup?
Yeah.
Because I'm a silly man. Turn around. No, I'm busy.
Why?
I teach him the boy hymn numbers. You need to learn them. Because these hard numbers are hard. Right, and you flush it over here. Okay, sorry about that. So any idea about this one?
Yeah, so there. So we want to find prove that angle AST is 90 degrees. So well, we know what angles do we know? So we know that AOB. So the angle AOB would be 180 degrees.
Okay.
The angle AOB is 180 degrees. And well, if that whole thing is 180 degrees,
So I don't think you really need any of those numbers.
okay.
What would be the size of the angle ORT?
Oh, that would be 90 degrees because it's a it's a tangent. Okay, that's fine. Yeah, because there are two so ORB OR was it ORT, sorry, equals 90 degrees. And because there are two what you call corresponding angles, we know that the corresponding angle to that, which would be AST.
And how do you know that OR and RT meet at 90 degrees?
Because it's a tangent from the.
Okay, so it says R is a point on the circumference on the circle.
Yeah.
And so therefore TR is a tangent.
Okay, right.
And also therefore what do you know about OR?
OR is the radius.
Yeah.
Okay.
Is a radius, yeah. And then what do you know about a radius and a tangent?
When they meet, they make they're perpendicular, so they make 90 degrees.
That's it. And then you would say the other stuff. So the angle between a radius and a tangent is 90 degrees. And then what is it? Angle ORT equals angle AST. Because like you said, corresponding angles are equal.
Okay.
Yeah.
Could I copy that down quickly?
Yeah.
So ORT. Okay, thank you.
Okay. Okay. Yep. Okay, how about this one?
So B, C, and D are points. So O, D, C. Okay, yeah. So, well, we know that there's two tangents there, and then if we divide the sort of kite shape in half, we could. Yeah. So if we did.
Maybe I'll just do something quick. Hang on. If we just go back a second. So this one here, our answer was 132. So what was this? What would be the two angles together? This one.
9. 90 degrees.
No. So we said this was angle SOT.
Yeah, so 66 degrees.
So this big angle, like, oh sorry, that big angle SOT was 132.
Yeah.
So what is the? So this one over here was 48.
Yeah.
So what's the connection between 48 and 132?
48.
And they're in this quadrilateral.
You add them together to get 180.
Yeah, and so that might be a quicker way. Instead of halving it and doubling it, you know that that's going to be 90 and that's going to be 90. So these have to add up to 360. These two add up to 180. So these two will have to just add up to 180.
180, yeah, okay. So then then that angle would be 140 degrees, angle DOB.
Yeah.
And then, so if we know that's 140, the outside angle would be, well, the angle opposite to that would be 40 degrees. What? No, sorry, 200, no. Yeah, no. 220 degrees. So that would be angle just outside there.
Yep.
So that would be 220. Yeah, so the angle DOB, but kind of opposite, would be 220, I think.
Okay.
So if that's 220, then angle DCB would be 70 degrees.
Mm-hmm.
Because that rule where there's a kind of like I can't remember the name of the rule, but it would be half that.
Yeah. The angle at the circle is half the angle at the center.
Okay.
Yeah.
Oh, yeah. So
they didn't ask for us to prove it, so we can just put that in.
Okay. Yeah. So then, if we have that length, so 70 and 220, and we know that angle OBC would be 15 degrees, because that's a tangent to the circle there.
Okay.
And 90 degrees. So then we want angle ODC. DC. So then we just have to have 360. Is it 360 minus 70 plus 220 plus 15? Okay. Which would be, if I can do this, so this would be 85. That would be, I think, 55 degrees.
Okay. Plus 70 plus equals 55 degrees. 55, yeah. Got it.
Could I copy that down quickly? Is that all right?
Yeah.
Okay, yeah, thank you.
Okay. Okay. Okay, how about this?
The points A, B, C, and D are on the circumference of a circle, and like TAQ is a tangent of the circle, angle marked X. So, okay, so I think there's a cyclic quadrilateral rule, which means that the angle, so the angle opposite 85 would be 95 degrees, wouldn't, no, 85 degrees, no, yeah, it's 95 degrees.
Mm-hmm.
So if we know that angle, we just have X to be equal to, I'll just write this down. So X is,
And so for this one, it says give a reason for each stage of your working.
okay.
So angle BAD equals 95 degrees. And what's the reason?
Because opposite angles in I think it's cyclic quadrilateral.
Yeah.
No, add up to 180 degrees.
Yeah. Okay, go
on. So then X is just 180 minus 95 plus 29, because angles on a line add up to 180 degrees. So angle X would be 180. So
that's it.
85 minus 30, 55. So 56 degrees. Angle X.
Because, yeah, angles on a straight line. Straight line add up to 180. And so X was, what was it, sorry?
56 degrees.
Okay. Let's see. Opposite angles of a cyclic quadrilateral add up to 180. So that's all they needed. They didn't even need the straight line bit. Okay, how about this?
So angle BC. BCO. So BC. BCO. So yeah, you'd have to draw so I'll draw this diagram. So you'd have to draw a straight line from, like, to make a sort of separate triangle. So BCO to be a separate triangle. Yeah. Okay. So, yeah, so that would be separated, and we know that angle BOC to be 140 degrees. We don't have to give any reason, so yeah, that's 140 degrees, and we know that angle. So there's two tangents there, so we can mark 90 degrees. I think yeah. So those two tangents would add up to be 90 degrees.
Okay.
Actually, yeah, because they're two radii coming out. Wouldn't angle AOB and ACB be the no? Would angle OBC and OCB be the same because they're two?
Yep.
Yeah. So then we'd know that angle OCB is, I think, 20 degrees. Yeah.
Yeah, that's it. So this one here is 140, and so these must be 20 each.
Okay.
Okay, that's 20. Okay, how about this one?
Angle 8. Angle X. Give reasons for the stages you're working. So, okay, so that's 56. So, Okay, yeah, so angle X would just be, because we know that, is that, no, that's not a radius, is it? So, I don't know, so, 3x. I'm not sure how you could approach this question.
So basically it's alternate segment theorem.
Okay.
Alternate segment theorem. Basically, BAQ is equal to BCA, which is equal to 75 degrees, because alternate segment theorem.
Okay, yeah. Yeah, I think I remember that. So, okay, so then that would be 75 degrees. And we just have, yeah, so X is equal to 180 minus 56 plus 75, which is 180. 49 degrees.
Okay. 9 degrees. 49 degrees, yeah. Alternate segment theorem and angles on a straight line add up to 180. So you need to say both.
Okay.
Okay, how about this one?
So A, B, C, and D are points on the circumference of a circle. AC is the diameter of the circle. Intersect at E. Okay. Okay, so if that's yeah, so if that would be 100 degrees for D, EC, we need to we know that angle AEB equals 100 degrees as well, because they're two crossing lines.
Okay. Which one, sorry?
Angle A. I don't think we even need that, because yeah, we want the yeah, so sorry. So that angle DEA would be 80 degrees.
Yeah.
And yeah, so angle DEA is 80 degrees. Angle AEB is 100 degrees. So angle ABE is 55 degrees.
Mm-hmm.
And well, we have those. So alternate seg. Wait, so alternate. And we know that CBE would be 35 degrees.
Yeah.
Because that's a right angle triangle there.
Yeah.
So, if we know that's 35 degrees, we would know that ECB, because angle CEB is 80 degrees, angle ECB is 100, so that would be 115, so 65 degrees for that one.
Okay.
So if we know that angle, we want... Okay, so that alternates, was it alternate segment rule?
So I don't think this would be alternate segment rule.
Yeah. No, I see the other one. So then angle ADE would be 65 degrees.
Okay.
So angle, yeah, we've got those two. And angle DAC would just be 180 minus 80 plus 65, which is 35 degrees.
DAC equals 35 degrees. Yeah. And 35 degrees. Okay, I can't remember the name of it, but yeah, basically the angles subtended on the same chord, I think it's called, are equal.
Yeah.
And so this angle here matches up with that angle there.
Okay.
And it's because you've got the two triangles. One was the right angled one, and then the other is that one.
Okay. Is it because the two triangles are kind of enlargements of each other? I was just wondering.
That's one way to look at it. So hang on. So it's because they are both sitting on the same chord. So the important bit is the chord AB.
Yeah.
So because they both have that side in common, they are both their angles match up. Their angles are corresponding.
Okay.
Yeah, so that angle there is the same as that, and I suppose this 65 here is the same as this 65 here.
Yeah.
Okay, and you're right, it would be an enlargement. Similar triangles, basically.
Yeah. So C and D are points on the circumference. Center center O. It's an equilateral triangle. So prove that ODA is an equilateral triangle. Okay. So I'll draw that. Okay, so angle CA, so all the angles in that bigger triangle would be 60 degrees.
Okay.
And the angle, so what's it? We know that those two are parallel. There are two sort of lines on the O, so the ODA. You know the line AB?
Yeah.
There are like two lines which would mean like the same side, but they're on a single side. Why is it?
The same size. So it means AM equals MB because M is the
Oh,
midpoint.
oh, okay, that's fine. So, yeah, if M is the midpoint, we know that. Well, yeah, we could get that subtending rule. Yeah, I was thinking. So if you draw two lines. Oh, okay. So yeah, okay. Yeah, no, I was thinking because if you had a line going from A to O and then from D to B, we could have two subtending like angles.
D.
And yeah, so
Okay. So from D to B.
yeah. Or was that not really?
So what could you do so far from just what we have?
Yeah, so we know that angle OAM is 30 degrees because that's the radius, and because that would go then to kind of half. Yeah, so that would be 30 degrees, I think.
Okay.
And then, sorry, so yeah, so that would be 30 degrees. And we know that AMO would be 90 degrees.
Mm-hmm.
So you can get AOM. So that would be 180 minus 30 plus 90, which is 60 degrees.
Okay. So 30 degrees.
Yeah.
Okay. Okay.
Yeah, so then if that's 60 degrees, and we know that, actually, because there's 30 degrees for OAM, OAD would be just 2 times 30, which is 60 degrees.
So why is that? Why is OAD 60 or why is OAM 30?
Because is it because there's a tan, well, you could have, I'm not quite sure how to.
So I don't, because you kind of just said the same thing twice in two different ways. So you said OAD is 60, so OAM is 30. And then you said OAM is 30, and so OAD must be 60. You know what I mean? And so you just kind of, you like they told you prove it's equilateral, but you just kind of assumed it's equilateral.
Okay.
So from what you have, are there any sides that could be the same length?
Well, we know that AM and MB are the same. From the smaller triangle.
Yeah.
Yeah, so we know that OA and OD are the same because they're both radii.
Yeah.
So those two are the same. Then that must mean that angle OAD and angle ODA are the same.
Okay. And so is there any way that we can show that? So we have OA, we have OD, we just need AD.
If you drew a line from D to B,
Okay.
we'd have two right-angled triangles there. We know that we know that they're sharing one common side, so that must be the same length. And there are two, so AM and MB are the same.
Mm-hmm.
So DB and AD must be the same length. And
DB and what, sorry?
DB and AD.
Why is that?
Because they're the same.
Oh, this is the same.
Yeah, and then they share
Then they share a common side. Okay. And so AD must be the same length as BD?
yeah.
Okay. And what about that?
Because they're the same length. And well, we know that OB is another rate. I don't know if I'm. What do you think I should do here?
So maybe let's say okay, so AM is a half of AB,
Yeah.
and maybe I don't know if this matters. AO is like a half of the diameter or whatever. A half diameter. Okay. So we need this final side. Ooh, I don't know. Let's take a look. OAB, ODA are isosceles. OAD, OBA. Okay. Hang on. OAB. So OAB. So that makes an isosceles triangle. And ODA also does. ODA. Okay.
Yeah, there are alternate angles there, but yeah, that would.
OAB equals 120 degrees. Sorry, AOB must be 120 degrees.
Okay.
Why is that? 20.
Well,
30, 60.
I think it's because.
Okay. No, from ACB. Hang on.
Yeah.
From A to CB equals 60.
Yeah, because it's an equilateral triangle mark there, and then we times that by 2 to get that.
Ah, yeah. Okay. And so from that, you can say that this is 60, that this is 60. Is that right?
Yeah.
So you can say that that's 60. And, oh, hang on. That this up here is 60. Because that's how this, no, sorry. Hang on. How is this one isosceles? OAD. That's the radius. And that's the radius. So it's that one and that one. Ah, okay. So then basically, yeah. So then these two here have to be equal to each other because it's isosceles. So I think the trick there, yeah, is saying ACB is 60 and so AOB must be 120.
Okay.
And then from that, a half of that AOD would have to be 60. We know that these two are equal angles because it's an isosceles triangle because they're both radiuses.
Yeah, okay.
And so it's like 180 minus 60 and then half it. And so all three angles are 60.
Okay, that makes sense, yeah.
And so it's just about actually writing it out. So what were they looking for? And appropriate method. The angle at the center circle is twice angle. So you just had to say that bit. Conclusion. And for the final mark, you have to say, therefore, ODA is an equilateral triangle.
Okay.
Which is just copied and pasted from the thing. From
the
question. Okay. Any questions there, Stefan?
I think that's fine.
Okay. If you like, I can send you the rest of the circle theorem questions.
Yeah, if you could, that'd be good practice. And then, if you could, that'd be great. Yeah.
Okay. Any idea what you want to do next time?
I don't know now. Is there anything that you wanted to do?
Not particularly. Just continue with the hardest questions, or we could just do revision of the easiest questions, like just the 1 mark questions for every topic, and the method mark for the 2 mark questions for every topic, just so you remember all the little things there, like what is the interquartile range or whatever, just little easy things that you might have just forgotten. That's all.
Yeah, I think that's a great, I think that'll be really good, yeah. Should we do that then next week?
Okay. Any questions for me in general?
Yeah, so with the further maths that I'm doing,
Mm-hmm.
uh, so is that exam like, would I take that at the same time as I take the GCSE for maths or?
So you're doing further maths, is it?
Yeah, yeah.
Yeah. So it's not on the same day, or it's not. It'll be slightly different, but yeah. So it's just another. It's just a different subject,
Okay, okay.
and so you just take it, and it's just a separate test.
Okay, that's fine. Okay.
Okay. Any other questions?
No, that's fine, thanks.
Okay. Well done, Stefan. You did great. I look forward to talking again next week.
Speak to you next week. Thank you.
All right. Have a good week. Goodbye.
You too. Bye.
Bye.